So thank you for joining us today. Today we'll be doing a demonstration of using service virtualization, or using service virtualization to help us test message broker and IIB flows and ESQL. This presentation and demonstration should go for about half an hour, so we'll try to keep it time boxed to that. So first off, what is service virtualization, and how can it help us? So service virtualization, according to Wikipedia, is a way of emulating components. So if you come from a development background, usually if you're writing a lot of Java code or C# code, you might be familiar with, say, Mockito and Java stubbing. So how is it different from stubs? So usually when we're talking about stubs, we're referring to something that's running in the same space. For example, if we mock out or stub a class. Using service virtualization, we're mocking or stubbing at an integration or component level. So if we're, in this case, mocking a real MQ service, a real message would be created on a real queue, and a real response queue will be read from. Or in the case of SOAP over HTTP, a real XML stream will be marshaled out, a port will be open, a TCP request will be sent, and a TCP response will be received. So what this means is we're able to test a lot more of our environment and our deployment, and we're testing a lot closer to what a real system would be doing. Rather than relying on internal memory stubs, we're relying on external stubs. So we can pick up issues with other component setup that we wouldn't be able to pick up in a completely isolated environment. Also, what this means using a service virtualization tool is you can do a lot more permutations, and you can emulate a lot more complex behavior. This is especially true when we start talking about some of the commercial offerings or some of the commercial tools, which we'll go through a bit later. So for example, you can change the request response times, for example, to simulate a slow connection or a connection that randomly drops. This means that you might be able to use non-developers with a service virtualization tool to develop all sorts of different scenarios to test your applications. Traditionally, stubbing and mocks has always been in the purview of developers and within their development toolset, such as Eclipse if you're doing Java, but a service virtualization tool potentially opens it up to non-developers and business people as far as developing scenarios. You can also do some interesting things, like you can randomize data sets to be more reflective of real data, and that randomization or selection of data sets is something that the business users and testers can actually do. Also, as far as randomizing data sets, a lot of service virtualization tools allow you to maintain those relationships. So when a particular set of data is used, all the transactions or interactions between components that you're trying to test using service virtualization can also react accordingly. So when you change a name of someone in the dataset, the whole set of interactions relates to that name, rather than a single static set in stone name that you'd get with, say, a unit test. You can also do some. You can also ensure that you've got correct correlation with the real service virtualization tool, so that you can correlate different request-response pairs more accurately. One of the other things that's very useful with service virtualization tools, particularly commercial ones, is it allows you to emulate responses for services that may not be completely developed yet, or have only been may only have their contracts defined. So you can mock services while another team, for example, is completing the development of that service. Service virtualization, by its ability to change responses according to requests, means you can also mock or stub a lot more of the edge cases than what you may usually be able to do. So this may include, as I was mentioning before, handling slow connections. This may include different types of faults or different permutations of different faults your system may actually receive back, and a lot more of your edge cases. So for example, if you had a service where you were doing a loan application for a 97-year-old man with 3 children and an income of $1.1 million a year, it might be extremely difficult for you to find real test cases or find real cases in production that you can generate test cases for from that. But with service virtualization, it's just a case of defining the responses applicable. There are a couple of other technical benefits of using service virtualization. If you don't want your developers necessarily, particularly if your services are external to the organization, if you don't want your developers particularly using external services to do their testing, you can use internal virtualized versions of them, which means that you may potentially not use up bandwidth going out and will be leaking information. So if you're using, for example, a Bloomberg's or a Reuters or some other charge per usage type service, you ideally don't want your developers using up those expensive services when they could be using internal mocked services. That also means if you're progressing down more of a self-contained or potentially Dockerized development environment, that might mean that you can have completely localized separated development environments where the developers have all the necessary components either really running as far as Docker containers goes, or as virtual services. So you essentially have a developer environment in a box. Some of the tools in this space that I mentioned are SOAP UI, which allows development of mocking services and also allows you to drive those services with the SOAP UI test harness. WireMock, which is what we're going to be using for this presentation. Parasoft Virtualize, which is a commercial tool. CA Lisa or CA Dev Test, which is a commercial tool, and a few others. This list is obviously not exhaustive. So for this demo, we're going to use WireMock to emulate our service. So we'll start from scratch with WireMock, not having any request responses set up. And for this demonstration, we're looking to mock an existing service rather than mocking a service which has not yet been defined and where we only have a schema for example. So what we're going to do is we're going to go into our test environment, into our test execution, and we're going to run our test and just see what our coverage looks like before we have service virtualization. So in this particular test here, what we're going to be doing is we're going to be sending a couple of test messages to our flows. Our flow looks like this: a SOAP request and SOAP response. We'll be testing our SOAP mapping logic following our SOAP call, where we're converting a number into a more descriptive word. Tiny, small, little, bigger, biggest. And with the test result. And that is what will be the logic we'll be testing. So what we're doing now is going to run an ANT script, and this ANT script I was just highlighting essentially just takes our bar file that we have. I'll just run that in the background. What we call instruments the bar file to give us our test coverage reports. Once we've instrumented our bar file, we're going to deploy our bar file, and then we're going to start running some tests in parallel. And these tests are sending these MQ messages which I mentioned before. So it'll just take a minute or so for us to run our test suite. So what we'll be doing next is just firing up SonarQube, and we'll be looking at the test coverage of those files relating to this particular message flow we're talking about. So now our test has finished running. What we're going to do is run the analysis of our project, and we're going to have a look and see what our test coverage looks like for that message flow that I showed before. So we'll go into our project, and we're going to look at our test coverage, and at the moment our test coverage is sitting around 30%. So that's not a bad starting point. So we're going to look at our coverage of our tests. What we can see here, the bulk of our logic, which we're interested in testing, has no coverage. So we can see here that this particular method is not being called, or this procedure is not being called. None of our paths through the piece of code are being tested, and so it looks like it hasn't actually hit our node. So we've stopped before we hit our node. If we go into our SOAP compute here, we can see that we've tested that we have mapped the incoming message to the SOAP values that we're making the call with. And we can see here in our failure node, we can see that our node has failed with an error code, and we're sending back our response of failed. So we can see that we haven't tested our primary path through our logic. What we've done is tested our error path through our logic. So what we're going to do now is start WireMock. And jump into our WireMock query, and WireMock is going to start. Default starts in like a listening mode, but we don't have any mappings at the moment, which are the request response pairs that WireMock is going to use. So what we're going to do is we're going to use WireMock to point to the external website that has this service deployed, and we're going to start running against that. So what we're doing is we're putting WireMock in record mode. So what this means is WireMock will record the request. It will make the actual call for us. It will accept the response. It will record the response and send back the response back to our calling application. So again, we're going to run our test cases again. So now our tests have finished running, and what we're going to do is we'll just have a quick look through the response from the build file, and we can see before where we're getting failures. We can see now, for example here, where we're getting back a response which looks like what we're expecting from our logic. So one of our values is returned back a mapping of biggest. We look at some of our other data. We can see here we've got some one of our calls has come back with a response of small. So we can see our logic being tested. So what we're going to do is we're just going to stop our WireMock, and we can see that we've captured 4 invocations and 4 responses. We'll now go back into our SonarQube. We'll run our analysis, and we'll just see what our coverage looks like now. Now if I go back into my report, we can see now that the coverage is 45.5%. So it was roughly 31%, now it's 45%. So we've added some additional coverage, which is good, which is what we're aiming to do. And now when we jump into our SOAP logic here, we get a different set of test results, or coverage results. So now we can see here, rather than previously this particular logic translation hadn't been called, we can see that the procedure has been called. We can see here of our 6 paths here, we've got 1, 2, 3, 4 paths have been covered, which is truly indicative of what we saw when we set up our 4 unit tests, because we set up 4 unit tests, so we would expect 4 paths to be covered from our 4th unit tests. We can see here that our mapping from our incoming message to our SOAP response, SOAP request has been covered. But what we've noticed down here is we've lost the coverage of our error handler, because where previously our error handler was being invoked when our SOAP service wasn't available, now our SOAP service is available. We haven't tested our error handler. So what we'd ideally like to do is say, well, okay, we've got 3 of our conditions tested. We'd also like to test our error handler. So if we go into what I mentioned before was the mappings, we can see inside the mappings we can see that particular requests, like a value of 2 and 4, returns a result of 6. Now what we're going to do, for the interest of how we've tested, is we're going to go and find the mapping for a particular value pair, which is 10, 2 and 5. So 10 and 10, which is the top one. And we can delete that file. And here's one we prepared earlier. We're going to go and grab one that does the same mapping of 10. But in this case, we're using service virtualization to make this server, for this particular combination, return a SOAP fault. So we've artificially introduced a SOAP fault for a particular pair of a particular request, so that we always get we are able to test our SOAP fault from our environment. So what we're going to do is WireMock is not a commercial tool, so what we're going to do is stop WireMock and restart it, because that's what we need to do to make sure that WireMock is able to pick up the new mappings. Now WireMock should start by default in a listening mode, which essentially means that it will be listening for incoming requests and sending back responses that it has. And if it can't find a response, it will try and match it to the closest one. Otherwise, it will fail and send back nothing. So what we're going to do now is we're going to run our test again. So our tests have finished running, and so what we're going to do is again look through our results from our build job, and we're just going to see what we've got. So in this case, we can see here that we're still getting a particular result for small, which is what we're expecting, but we can also see here when we've sent our 10 plus 10, which is the request that we were going to use to simulate a SOAP fault, we can see here that the result we've got coming back is actually is a fail without a valid response. So what we do now is when we run our analysis, we'll jump back into our project. We can see we've still got a high level of coverage, but it's interesting is that, or what is interesting here is that we've actually dropped our coverage slightly from 45 to 43. And that's most likely because we've lost one path. We've traded one path of coverage for one path of coverage for the logic to one path for the fault handler. So we can see here, in our actual logic, we can see here now we've only got 1, 2, 3 paths of the code that's actually being covered, while previously we had 4. We can see we're still covering our mapping, and then we can see we've actually added back our test coverage for our fault. So we know in the case of an error that it works, that our process for capturing a fault works, which is a good place to be in. Which is, yes, a good place to be in. So what we can show now is we've used service virtualization to record some requests and responses. We're able to change one of those requests and responses in line with our requirement, so that now that we're able to test our fault path as well as our successful business logic path. So what we'd normally do now is a development team would look at these results, and we'd work out whether or not those alternate paths are worth testing. If they are worth testing, we'd add more unit tests to try and ensure that we've got all our paths tested. So what we're going to do, we'll leave it that as is. But what we'll do is we'll pretend that the time has passed, and what we're going to do is show what it looks like when someone changes some logic and we have our existing mocks in place. So what we'd most likely do now as a team is we'd take these mocks, we'd add the results to our version control system, and so as part of our regression testing we would include this part, the deployment of the mocks and the starting of the mock server as part of our test case. So our test case would be create a bar file, instrument a bar file, start our mock server, run our tests, stop our mock server, run our analysis, and just see how our test coverage looks and whether or not all our tests passes. So what we're going to do is we're going to pretend that we've jumped forward in time, and we're going to add some new code. So our business users have come back to us and said, yes, we like our little number conversion function or number conversion message flow in Broker. It's all good, but a couple of weeks later, or a period of time later, they've come back to us and said, well, we've got more actual paths or logic that we want you to add. So what we'll look at here is a developer comes in and goes, okay, well, this is where I need to make the coding change, and what I'm going to do is I actually need to make it we had to add a few more descriptions relating to our logic. We've added a new definition there, and we may, for example, have changed some of the ranges. So our developers come in and they've made some changes to the groupings here for different mappings, so slightly different response and slightly different mappings. And as part of the development process, they'll be hopefully running these regression tests locally. Otherwise, when we run them up on the build server, when they check in the code, we should start seeing some slightly different results as far as our test coverage goes. So our build script and tests have finished, and hopefully our tests will pass. We're going to run our analysis again. And we'll jump back into Sonar, and we'll have a look at what we got. And what we can see here is we've made some changes to our code, and our coverage has actually fallen by roughly 5%. So it was 43% or roughly 43%. And adding some new code has created some new paths through the code. And so Sonar has calculated that the coverage is actually less, because even though we had the same number of tests being executed, we've actually got more paths that we need to test. So this time when we go back in, we'll have a look and see what we've got here. So previously we could see that the compute module had been tested, which is still being tested, but previously we had 3 paths through the code being tested, and now we've only got 2. So our 3 test cases is covering less of our paths through our code. And so what that means is, as a developer, I should be getting the feedback now, potentially ideally from the build server, to indicate that previously, before you made your changes to the code, the coverage was roughly 43%, and you've made the test coverage drop, which you can set up through SonarQube profiles and quality gates. But we can cover that later in a different presentation. But the takeaway for the developer is the only thing that's changed in the regression testing suite is the developer's code. The tests have remained the same. the coverage to drop because of what the developer has done. So what the developer needs to do is go back to the mocks available and the test cases, and he or she will have to go in and create some new test cases to reflect the new scenarios or the new paths for the new scenarios being tested. Generate some new test cases or the necessary request response pairs for the test, and their request response pairs for the mock. Add those test sets to the test suite, add the mocks to the mock suite, and then ideally they would be able to get the coverage back up to where it was previously before their change, which we won't demonstrate now, but hopefully it should be clear from the first part of the demonstration how to do that. So thank you for joining us for our presentation on using WireMock to provide service virtualization for testing a message flow. Hopefully the takeaway you get from this is that message broker code can be tested. There are tools to help support testing of message flows, and that there's some good automation you can do with the use of ANT or Maven and some of the other tool sets available, including WireMock for service virtualization. I think that hopefully that one of the big takeaway here is that we can over time improve the quality of our code, and as using some of this automation and using the service virtualization technology, we can actually build a quality loop where after a developer has made a change, they were able to get some feedback on the different parts of the code that they haven't tested, and using service virtualization and mocking, they should be able to go in and add the additional test coverage so that they can get verification that they have done the necessary, that their logic is successful and correct, and that they have done the necessary testing as part of the unit and regression testing parts of, say, a continuous build server. Again, thank you for joining us today. If you do have any questions, please feel free to jump onto our website, bettercodingtools.com, or contact me via LinkedIn or via our contact page on our website. Thank you again, and enjoy the rest of your day.